Greetings everyone. Welcome to the talk on Office Document Security and Privacy at the 2020 Virtual Usenix WOOT conference. My name is Jens Müller. I'm a PhD candidate at the University of Bochum in Germany. And today I will give you an introduction to our research, which is a joint work from Bochum on dangerous features of Office documents. So basically the idea of this research was to systematically check if we can find something by maybe having a deeper look at the standards of Office document formats. Here's an outline of today's talk. First, I'm going to give you some background information on modern Office documents, which are based on OOXML or ODF as used by Microsoft Office and LibreOffice. Then I'm going to introduce 5 attack classes based on malicious documents, which lead to denial of service or tracking the document usage, information disclosure attacks that may result in leaking personal data, the manipulation of data such as local files, as well as even code execution on the victim's machine. And finally, I'm going to provide an evaluation of those attacks. Okay, let me start with some technical backgrounds on OOXML and ODF. Let's have a quick history lesson on Office Wars. In 1990, the very first version of Microsoft Office was born, which back then used a proprietary data format. In the early 2000s, OpenOffice.org was released as open source, which back then was based on StarOffice. Now in 2006, OOXML, the modern data format used by Microsoft Office, got standardized, as well as ODF, the open document format as used by OpenOffice. And finally, in 2010, LibreOffice started as a fork of the Open Office project. So until today, we have those two competing XML-based Office document formats, those two standards, OOXML and ODF, as used by Microsoft Office and LibreOffice, the de facto standard Office suites on the desktop. Note, however, that those Office suites claim at least partial compatibility for each other's native file format. So for example, modern versions of Microsoft Office, they can also open ODF files created with LibreOffice Writer and the other way around. Now, interestingly, both data formats are actually zip archives. Sounds interesting. Let's unzip. You can simply unzip Office documents using standard tools, and you'll find a directory structure like this for OOXML, containing files for metadata, for images, and so on. The most important file, however, is document.xml, which contains the actual textual content of the document. Now let's have a closer look at this file. Here's a minimal example for a document.xml, which simply displays Hello World when opened. And ODF files, when unzipped, they have a similar directory structure. Here the actual document content is contained in the content.xml file. And once again, we can craft a simple, minimal Hello World content.xml file. Now, before coming to the actual attacks, let me first introduce the attacker model. So our attack scenario is as follows. All the victim has to do is open a malicious OOXML or ODF document provided by the attacker, for example, by email or download from the internet. And once the document is opened, bad things happen depending on the attack. So for example, for denial of service attacks, they would cause the Office suite to consume all available system resources. Our methodology in finding the attacks based on malicious Office documents was pretty simple. We basically systematically studied the OOXML and ODF standards for legitimate features that are critical from a security point of view and which could be abused for attacks. We then classified those attacks into 5 classes, and now let's start with denial of service, which contains only one attack, deflate bombs. So, data amplification attacks based on malicious zip files or zip bombs are probably well known to the audience. However, OOXML and ODF documents, they are actually zip archives. And to open them, applications must first decompress them, which raises the question if compression bombs based on malicious Office documents can be built. Therefore, let's once again have a look at our Hello World OOXML example. And now instead of Hello World, let's create a valid XML content structure to display a very long string, AAA, and so on. Now this results in a compression ratio of 1 to 1023, which is the maximum compression ratio that can be unfortunately achieved with the deflate algorithm. However, note that there may be some more advanced tricks to create even better zip bombs, as shown by David Fifield on last year's WOOT. Okay, now let's proceed with invasion of privacy attacks such as silent URL invocation and document metadata. Let's start with URL invocation. The goal of this attack is to craft a document that silently phones home once opened, which can be used to track document usage. An attacker could use this to de-anonymize users, for example, journalists or activists behind a shared mailbox. To test for URL invocation, we systematically studied the XML syntax of OOXML and ODF for legitimate features that allow to trigger a network connection. Now, similar to tracking pixels in HTML emails, removed images can be included in both file formats. So a straight format method to achieve this is OOXML relationships, which basically bypassed the stealth mode in LibreOffice. And in ODF, external documents can be included by setting their URL to the value, for example, of a native attribute of a draw image XML tag. The next issue is metadata. There are various examples of unintentional metadata exposure in Office documents. For example, in 2003, when the orders of a document published by the UK Prime Minister's Office were unintentionally revealed. Now the question arises if modern Office suites still silently include potentially sensitive metadata. At least Microsoft Office does, which is not always desired. So as you can see here, Microsoft Office does not only store relatively harmless information like the timestamp of the document and the creation date and the software that is used to generate the document, but also the author's name, which is derived from the name of the currently logged in user into the Windows operating system. Now this is a feature, but it may be more privacy preserving to avoid including such excessive amounts of metadata by default and instead let users opt in. Now our next attack class is information disclosure, leading to the exfiltration of spreadsheet data, local files on disk, or even NTLM user credentials. Let's start with spreadsheet data exfiltration. The idea of this attack is as follows. The victim downloads an OOXML or ODF spreadsheet from an attacker-controlled source, like, for example, a spreadsheet template to track personal finances, and then inserts sensitive information here. Now the goal of the attacker is to leak all user input, for example, personal information regarding the victim's financial situation. To achieve this goal, the attacker manipulates the spreadsheet in such a way that cells containing sensitive data are referred to and concatenated, for example, as the path of a hyperlink to the attacker's web server evil.com. So in case that the user clicks on this hyperlink, which can be further obfuscated, the content of those cells is exfiltrated. Another option is to use the web service function to automatically leak the spreadsheet content once the document is opened. However, it must be noted that in both Microsoft Office and LibreOffice, for the web service function, the user is now asked to update the content before invoking any connection. Our next attack is file disclosure. So the ODF standard provides various features which enable a document to access and include local files on disk. For example, the target of removed images can be a file URI. You can even include arbitrary text files on disk, like the victim's SSH private key, which looks like this in LibreOffice. Now we were not actually able to exfiltrate the content of embedded files using, for example, that web service function or things like that, but there may be other potential exfiltration channels. So for example, when this malicious document is now resaved and exported by the victim to PDF, a copy of the file on disk is silently embedded into either the PDF or the saved ODF zip file container archive, which could be bad in a scenario where the attacker gets access to the newly saved document. For example, if the victim is asked to review and add feedback to an attacker-controlled document. Now let me show you how Office documents can leak NTLM hashes for Windows user credentials. So in 1997, Aaron Spangler posted a vulnerability to the Windows NT backtrack mailing list, which can be summarized as follows. Any client program can trigger a connection to a malicious SMB server. Now, if the server requests authentication, Windows will automatically try to log in with a hash of the current user's credentials. This is a well-known design problem of the Windows operating system. Now, in both OOXML and ODF, this can be achieved with removed images that refer to a network share. And this attack works for both Microsoft Office and LibreOffice. Now, such captured NTLM version 2 hashes allow for efficient offline tracking, for example, using Hashcat. Previous versions are actually trivial to crack and they can be considered as broken, as shown, for example, by Moxie/Marlinspike and others. Or you can also use NTLM hashes to perform relay attacks and authenticate under the user's identity, as shown, for example, by Oshoa and Hummel. Of course, it's up to the configuration of the victim setup, for example, the password strength and security policy, if such attacks are actually feasible. The next attack class, data manipulation, deals with the capabilities of malicious Office documents to write to local files on the host's file system or to mask their content based upon the opening application. Okay, let's start with how malicious documents can write to local files. OOXML and ODF documents, they can contain forms to be filled out by the user, which is a feature used daily in typical Office tasks like, for example, to file claims or business applications. Now, similar to HTML forms, the contained form data can be submitted to a URI, for example, to an external web server. ODF implements the XForms W3C standard, which allows data to be submitted without the need for macros or other active scripting. Now, the XForms specification allows various methods like post, get, or delete, and the target of a form submission can even be a local file on disk. So, if natively implemented XForms in ODF documents, they may be used to overwrite or delete arbitrary files on the user's file system. So here's the XML source to write to new file in the user's home directory. The form is triggered by a button, but this button can of course be set to look like normal text or to cover even the whole document. And thereby a single click somewhere into the malicious document triggers the form submission and writes the contained form data to the specified target. Now, to our surprise, this allowed us to write to, overwrite, or delete arbitrary files on disk in LibreOffice, resulting in a recent patch. The goal of content masking attacks is to craft Office documents that display different content depending on the application used to open the document. This can be a security problem in cases where the document content must be unambiguous, such as sales agreements or business contracts. To test for content masking attacks, we studied the OOXML and ODF standards for ambiguities at the level of the directory structure as well as the XML structure. For example, a Hello World document could contain multiple body nodes. In such a case, processing applications need to decide which one to process, which leads to confusion between both tested Office suites. Also, we could have a look at the directory structure. ODF defines the main content file to be named content.xml. However, the specification does not make a statement regarding case sensitivity. Now, by placing two open document content files with mixed case names into the ODF container, we were able to enforce a decision regarding which file is to be processed by the applications. So LibreOffice parses the first one, while Microsoft Office uses the second file. Last attack class is code execution based on malicious documents, which is naturally done using macros. As you would expect, the execution of macros is disabled by default, and the user has to explicitly enable them in both Microsoft Office and LibreOffice. However, once enabled, until today there's no limitation regarding macro capabilities. For example, shell command execution in OOXML and ODF is still possible. Now, this is not a vulnerability, but during our research we discovered some further additional findings, some further weaknesses that led to code execution in both tested Office suites. When we initially started this research back in 2018 and tested for UL invocation in Microsoft Office, we stumbled upon a memory corruption caused by a piece of HTML code. And to our surprise, Microsoft classified this accidental finding as remote code execution in Microsoft Office with a CVSS score of 9.3. Furthermore, we found that the feature to submit X forms to files on disk can be escalated to code execution in LibreOffice. One way to achieve this is by submitting malicious XML data to the configuration file of LibreOffice itself. The malicious XML displayed here contains new configuration settings to allow arbitrary macros, which can then be automatically launched, for example, once the malicious document is closed, in order to execute arbitrary shell commands. So let me come to an evaluation of the attacks. Microsoft Office could be forced to hang and consume all available resources using deflate bombs, while LibreOffice stopped after providing around 4 GB to disk. Your invocation is a legitimate feature of both Office suites, while only Microsoft Office includes usernames into metadata. Spreadsheet data exfiltration requires user interaction in both Office suites, and only in LibreOffice we had limited file inclusion without exfiltration, while NTLM credentials could be leaked in both Office suites. We could write to or delete arbitrary files on disk in LibreOffice, while content masking attacks had some limitations in Microsoft Office. A working proof of concept for code execution in LibreOffice could be provided, while we classify the memory corruption in Microsoft Office as somewhat limited. Okay, let me quickly provide some countermeasures. So obviously the standard should remove some dangerous features that are rarely used, such as the possibility, for example, to include external files within a document. Office suites, they should not allow documents to silently open network connections or include excessive amounts of metadata. Also, resources could be limited to counter compression bombs. And finally, to counter content masking attacks, the specification should be precise, thereby allowing new room for interpretation by implementations. Okay, let me come to an end of the talk. So both OOXML and ODF, they're not simple documents formats. They're really complex with a lot of potentially dangerous features. In this work, we provided a study on such insecure features of Office documents, leading to, for example, code execution based on a one-click pure logic chain exploitation in LibreOffice. Okay, thank you. You can find all the exploits and artifacts online on GitHub.